Hello everyone. Today we are starting our next unit number 4, methods of separation. Methods of separation. Okay. So for this semester, you have part first for the methods of separation, and for the next semester, you have part second. Okay. So it carries total 25 marks for this semester. So what things we are going to learn here? So first we are going to see what is a solvent extraction. Solvent extraction. Okay, so with the help of any organic solvent, we are trying to extract organic substance from the aqueous layer, or aqueous means water. Okay, aqua means water. So we are always going to try to extract a organic substance from the water into the organic solvent. So different factors are there that affects the extraction. First is the chelation. We'll see one by one in detail. Already we have seen what things are included in the syllabus, but again I'm trying to remind you what new concepts or what concepts are included under this topic. Then after that, ion pair formation, and third is solvation. Okay. After that, we are going to see the graph of percent extraction versus pH. Graph of percent extraction versus pH. Okay, versus pH. Then concept of pH 1 by 2 and its significance. Okay. After that, we are going to see Craig countercurrent extraction, the principle of Craig countercurrent extraction, the apparatus, and what are the applications of Craig countercurrent extraction. Okay. Then one more concept is there, that is solid phase extraction. Okay. We are going to see principle, then process, and application with a special reference to water and industrial effluent analysis. Okay, so for these two things, basically we are going to study this technique and how that technique is utilized over here. Okay, means for the purification of water or the treatment of water, and for the industrial effluent analysis. Then after that, see a comparison of solid phase extraction and solvent extraction. Okay, so these two techniques we are going to compare with each other. Then high performance liquid chromatography. Okay, so we are using here pressure, and with the help of pressure we are trying to push the solute from the column so as to make separation with the more speed. Okay, and with the greater efficiency. Okay, these things we are going to study here. So as usual, the principle will be there first. After that, instrumentation is there. So different things will comes under the instrumentation, and at the end there should be the applications. Okay, applications. Then high performance thin layer chromatography. We have studied a thin layer chromatography in SYBSC. Only we are using here the pressure. Okay, and by the help of which we are trying to separate the component. Okay, and this technique is having many more advantages over the TLC technique, but TLC technique itself having its own applications. Okay, and that can be used at the ground level. Okay, so when you will go to the research, so the basic technique, you try to monitor the reaction over there is TLC. Okay, so in this technique we'll see what detects. Basically for each and every instrumentation we go first for the principle, after that instrumentation. Okay, then detectors are there. Okay, two detectors We are going to study over there. After that, advantages, disadvantages, and applications are there, and comparison between TLC and HPTLC. Okay, TLC and HPTLC. So this is what your first topic, first slide of this topic is a solvent extraction. Topic is a solvent extraction. See, so it is a liquid extraction, okay, and process is based on the distribution of a solute between two immiscible liquid phases. Between two immiscible liquid phases means stationary phase is also liquid and mobile phase is also liquid. Stationary phase and mobile phase both are here as a liquid. Okay, so that's hence the name is liquid extraction. Okay, now here no stationary phase, actually it says a liquid extraction. Okay, so in the slide I will show you, here it is. So that would be there for the the HP high performance liquid chromatography, stationary phase and mobile phase as a liquid we are going to see over there. Okay, so please don't get confused. So with the flow I told you about the HPLC. Here in the solvent extraction, both are the liquid. So one of the phase is a aqueous phase and other is a organic phase. Okay, or the organic solvent. So we'll see that in the detail. See, one or more solute dissolved in a solvent are brought in contact with the immiscible solvents. Okay, the solute will get transferred to the second solvent, that you can say as organic solvent. For the separation, one of the solutes should get transferred to the other. Okay, that means one should get transferred to the organic phase and other should remain in organic original solvent. Means one should get to the organic solvent and other should remain in the original solvent. What original solvent? It's a aqueous layer. It's a aqueous layer. Okay, as I have told you in the SYBSC only, how we are separating the solute present in aqueous phase. Okay, so this technique is used basically after completion of reaction in the organic chemistry, and once the reaction is completed, for the removal of impurities, especially the solvent extraction technique is used. And in the broad sense, you can say that this is the technique you need to use after completion of each and every reaction. Okay, in a broad sense. Okay, it is not specifically for each and every reaction, but in broad sense means its use is a very, you know, for in a particularly while setting the reactions in the laboratory, research laboratory, we start to carry out experiment in a means on a very small scale. Okay, and at that time we need to follow this technique. Okay, because at the first step only, it is not necessary for each and every time you will get the solid product. Once you get the solid product, you can filter it, but it is not necessary every time you should get the solid product. Okay, and hence I told you the technique is used in each and every reaction. Okay, so experimental conditions are maintained in a such a way that transfer of one solute in a second solvent is a total. One of the solute from the aqueous phase should get transferred to the organic phase. Okay, so let me go to the second slide and then we'll come back to this slide so that it will be more easier for you to understand. आता बघा या ठिकाणी what happens here, this is a mixture. Okay, suppose this is a water and in the water 2 to 3 components are present. Okay, so one of the solute is shown in a red, other is shown in a blue, and a third one is shown in a green. So once you pour organic solvent in this, okay, and if you separate, you shake it vigorously and allow it to stand for some time, so automatically organic layer will get separated from the aqueous layer, and in that case you can separate organic layer from the aqueous layer. See, here actually this is taken from another source and this is taken from another one more source. So don't get confused because you cannot see that square, triangle, and circle in this slide. So to make it clear for you, I have taken one more a picture over here. This is your picture now. Just concentrate here. What I am saying. See, suppose this is your aqueous layer. Okay, and there are two components. One is shown like this, blue dot or black dot. Now there is with the red dot. Now if I am pouring organic solvent to this, so now there are two layers. Okay, now I shake it vigorously. See, now two layers get separated from each other. Okay, this is one layer and this is organic. This is on another layer. Okay, so these are the two solvents. Suppose this is aqueous phase, aqueous layer, and this is the organic layer. Okay, so they are get separated. Once मी हा कॉक चालू केला की हळूहळू काय होतं की जो aqueous layer आहे तो ट्रान्सफर होतो. कुठे ट्रान्सफर? इट गेट ट्रान्सफर टू द बीकर. Okay, and once this level come to this stage, instantly what I'm going to do, I'm closing this cork. So what happened now? Both the layers are get separated, but at the end of separation you can see one of the component which I told you, two components were there. One was shown in a black dot and other was in the red dot, or you can say pink dot. So see, these components goes along with the aqueous phase, and whatever black dots are there or the solutes are there, other solutes are there, other type of solutes are there, they comes with the, or they are written with the organic phase. Okay, and you can take it to the another beaker. By this way you can separate the two solutes from each other. Okay, or you can extract this solute, black dot solute. This is just for understanding. Don't get confused that such a black dot solute and pink dot solutes presents in the aqueous phase. म्हणजे असं काही समजू नका. पण तिथे दोन प्रकारचे सोल्यूट आहे असं समजा. त्यातला एक पाण्याबरोबर खाली जातो आहे आणि दुसरा जो आहे तो ऑर्गॅनिक फेज बरोबर वरती राहतो आहे. ओके, आणि आपण हा सेपरेट करू शकतो. ह्याच टेक्निकला काय म्हणतात? एक्स्ट्रॅक्शन टेक्निक म्हणतात, सॉल्व्हेंट एक्स्ट्रॅक्शन म्हणतात. बघा आता या ठिकाणी separation takes place on the basis of Nernst distribution law. Okay, so partition coefficient and distribution ratios are a very important concept. Okay, over here the distribution or partition of the solute between two miscible solvent is governed by, or it works on the basis of Nernst distribution law. जे सेपरेशन होत आहे ना त्या दोन सोल्यूटचा, है ना, ह्या ठिकाणी जे सेपरेशन झालं ना, हे सेपरेशन कोणत्या बेसिसवर झालंय? नर्न्स डिस्ट्रीब्यूशन लॉच्या बेसिसवर झालेलं आहे. ठीक आहे ना. Solute A will distribute itself between two immiscible liquid in a such a way that the ratio, it should be ratio of the concentration of the solute in two immiscible phases is a constant at a constant temperature. म्हणजे तो जो रेशिओ आहे 25 डिग्री सेल्सिअसला आज जे डिस्ट्रीब्युशन झालेलं आहे, ओके, तेच डिस्ट्रीब्युशन उद्या पण व्हायला पाहिजे या टेम्परेचरला. आणि ज्या प्रोव्हाइडेड दॅट ऑल कंडिशन शुड बी कॉन्स्टंट. ओके, द व्हॉल्यूम अँड एव्हरीथिंग शुड बी द कॉन्स्टंट. ओके, द लॉ इज व्हॅलिड ओनली इफ मॉलिक्युलर कंडिशन्स रिमेन सेम इन बोथ द सॉल्व्हेंट. म्हणजे त्या सबस्टन्सच्या मॉलिक्युलर कंडिशन ऍक्वियस फेज मध्ये आणि ऑर्गॅनिक फेज मध्ये ज्या आहेत ना त्या सेम राहायला पाहिजे. नाही तर बऱ्याचदा काय होतं, असोसिएशन आणि डिसोसिएशन होतं, ते होता कामा नाही. असोसिएशन डिसोसिएशन झालं तर दॅट कॅन नॉट verify the Nernst distribution. Okay, so suppose C1 is a concentration of solvent in solute in a solvent 1, and C2 is a concentration of solute in solvent 2. Then at any given temperature K is equal to C1 upon C2, where K is called partition or distribution coefficient. हा जो K आहे ना त्याला काय म्हणतात? पार्टिशन किंवा डिस्ट्रीब्यूशन कोएफिशिएंट म्हणतात. Okay, what is the K? It's a ratio of concentration of solute in solvent 1 to the solvent 2. Solute तोच आहे पण कॉन्सन्ट्रेशन हे एका सॉल्व्हेंट मध्ये आहे आणि हे दुसऱ्या सॉल्व्हेंट मधलं कॉन्सन्ट्रेशन आहे. ओके, जे की एकमेकाबरोबर काय केले होते, मिक्स केले होते विगरसली. असं समजा पाणी घेतलं 1 लिटर आणि त्याच्यात पेट्रोल 1 लिटर टाकलं आणि ते जोरामध्ये शेक केलं, आणि त्या पाण्यामध्ये समजा एखादा कलर असेल गेलेला, तर शेक केल्यानंतर त्यातला काही कलर, तो जर ऑर्गॅनिक सबस्टन्स असेल कलर, तर तो काय होईल, पेट्रोलमध्ये पण त्या ठिकाणी वरती, पेट्रोल आणि पाणी तर काही एकत्र राहणार नाही, जरा वेळ ठेवलं तर पेट्रोल वरचा लेअर पेट्रोलचा असेल, खाली पाणी असेल, बरोबर ना. मग त्या पेट्रोलमध्ये तो कलर निघून येतो आणि पाण्यामध्ये अगदी थोड्या प्रमाणामध्ये तिथे राहतो. म्हणून त्या कलरचं कॉन्सन्ट्रेशन इन पेट्रोल अँड कलर कॉन्सन्ट्रेशन इन वॉटर यू कॅन से. ओके, जस्ट फॉर अंडरस्टँडिंग पर्पज. What happens if the molecular conditions not remain same means if the molecules undergo association or dissociation, in that case the partition coefficient or distribution coefficient, okay, or distribution ratio can be termed as a, see this can be termed as a, see that is shown by term D, that is shown by term D, that is distribution ratio, that is distribution ratio. Okay, here in this case that distribution coefficient will become now distribution ratio. कधी जर मॉलिक्यूल असोसिएट किंवा डिसोसिएट होतात, ते रिॲक्ट होत आहेत, है ना, त्या केसमध्ये then total concentration of A in all forms in solvent A may be associated, dissociated, and total concentration of solute in solvent B in all form, okay, that may be associated, dissociated. Okay, this is solvent second, this is solvent first. So कुठलाही फॉर्म असू दे त्या सोल्यूटचा, असोसिएशन असू दे, डिसोसिएशन असू दे किंवा आणि काही दुसरा असू दे. ओके, सो what factor affects on the extraction? See, solvent or solvent mixture utilized, then solvent to raw material ratio, then raw material particle size, then temperature of extraction, then duration of extraction, then extraction vessel agitation speed. तुम्ही खूप जोरामध्ये त्या ठिकाणी मिक्स केलं तर त्या ठिकाणी एक्स्ट्रॅक्शनचं प्रमाण जे आहे ते व्हॅरी होईल. ओके, टेम्परेचर चेंज केलं तरी एक्स्ट्रॅक्शनचं प्रमाण व्हॅरी होईल. आणि एक्स्ट्रॅक्शन व्हेसल व्हॉल्यूम, तुम्ही किती व्हॉल्यूम वापरतायत एक्स्ट्रॅक्शन व्हेसलचा, दॅट ऑल्सो मॅटर्स. हे बघा, या ठिकाणी एक्स्ट्रॅक्शन करण्यासाठी आपण जे वापरतोय ना, किती प्रमाण वापरलंय, कुठला किती व्हॉल्यूमचा हा फ्लास्क वापरलाय, किती टेम्परेचरला एक्स्ट्रॅक्शन केलाय, किती जोरामध्ये तुम्ही तो भांड शेक केला एकमेकांमध्ये मिक्स केल्यानंतर, है ना, ते किती वेळेस एक्स्ट्रॅक्शन केलेलं आहे, है ना, त्या रॉ मटेरियल पार्टिकलची साईज काय आहे, तर ह्या सर्व गोष्टी त्याच्यावरती इफेक्ट करतात. Okay, so solvent extraction is also known as a liquid extraction. It is a method to separate compounds based on their relative solubility into different immiscible liquids, usually water and organic solvent, any organic solvent. म्हणून मी वारंवार ऍक्वेस किंवा वॉटर जे म्हणतोय त्याचं कारणच ते आहे. ओके, so efficiency, what the concept of efficiency of extraction? ओके, इफिशियन्सी, त्याची कार्य करण्याची क्षमता किती आहे, की एक सिंगल वॉश दिला म्हणजे एकदा मिक्स केलं 1 लिटर पेट्रोल आणि 1 लिटर पाणी आणि शेक केलं तर सगळा कलर पाण्यातून पेट्रोल मध्ये आला, तर त्याची जास्तीत जास्त इफिशियन्सी असं म्हणूया. पण असं शक्यतो होत नाही. म्हणजे काय करावं लागणार आहे, अर्धा लिटर करूयात पेट्रोल, पहिल्यांदा अर्धा लिटरचं वॉशिंग देऊ, पुन्हा अर्धा लिटरने हे करूयात. किंवा थोडक्यात कपडे धुताना तुम्ही एका पाण्याने फक्त एकदाच कपडे धुतले आणि तोच कपडा तुम्ही ते पाणी 2 ठिकाणी केला आहे आणि तो कपडा पहिल्या पाण्यात धुतला आणि पुन्हा दुसऱ्या पाण्यात धुतला, तर 2 वेळेस वॉशिंग केल्यानंतर डेफिनेटली कपड्याची जी स्वच्छता आहे ती जास्त होते. त्याला मल्टिपल वॉशिंग म्हणतात आणि त्याच टर्म मध्ये इफिशियन्सी ऑफ एक्स्ट्रॅक्शन असते. ओके, तुम्ही जास्त वेळेस तेवढाच व्हॉल्यूम असू देत सॉल्व्हंटचा, पण जास्त वेळेस एक्स्ट्रॅक्शन जर केलं ना तर ते काय होतं की तुमचा जास्तीत जास्त सोल्यूट हा ऑर्गॅनिक फेज मध्ये येतो. ओके, ऑर्गॅनिक फेज मध्ये येतो. समजा की इथे पेट्रोल मध्ये येतो असं समजा, जे की आपण एक्झाम्पल घेतलंय, आता तेच आपण वारंवार वापरणार आहोत फॉर द नेक्स्ट understanding of the concept. So when solute is extracted from aqueous solution using organic solvent, the efficiency of extraction is greater when the distribution ratio D or distribution coefficient K is in the favor of organic solvent or far greater than unity, so that the concentration in organic layer is appreciably greater than that of aqueous layer at the equilibrium. Should be greater than that of the aqueous layer at the equilibrium. ओके, बघा, म्हणजे जास्तीत जास्त सोल्यूट हा कुठे गेला पाहिजे, ऑर्गॅनिक लेअर मध्ये गेला पाहिजे. हा ना, वरती एक लेअर आहे आणि खाली एक लेअर आहे, दोन लेअर हे कशात एका भांड्यामध्ये आहे. तर तो ऑर्गॅनिक लेअर मध्ये जास्तीत जास्त राहायला पाहिजे. The efficiency of extraction is greater when small volume of solvent is used for multiple extraction. मी काय बोललो तुम्हाला, कपडा 3 वेळेस धुतला तेवढ्याच पाण्याने, पण ते पाणी 3 ठिकाणी केलं होतं तुम्ही. तुमच्याकडे 50 लिटर पाणी आहे तर ते किंवा 45 लिटर पाणी आहे, 15 लिटर 3 ठिकाणी करा आणि कपडा त्याच्यामध्ये धुवा 3 वेळेस, स्वच्छ होईल कपडा. पण एकदाच 45 लिटर मध्ये एकदाच वॉश केला तेवढा स्वच्छ होत नाही. So same concept is applied over here. So distribution ratio is defined as the concentration of solute in organic phase to the concentration of solute in aqueous phase. Okay, so see, this is the concentration of solute in organic phase, this is the concentration of solute in aqueous phase. Okay, the concentration of organic phase here should be the concentration of solute in organic phase. So percentage extraction is given by E is equal to 100 into D, 100 into D. What is D? Now you know the D, we have studied what is D. D is a distribution ratio. Okay, upon D plus volume of aqueous phase plus volume of organic phase or organic layer. Okay, this is what the formula. Therefore, percentage extraction, how you can, here already multiplied by 100. Okay, already multiplied by 100. Hence, you can write it in the percent. Now, what is the concept of separation factor? This concept of separation factor is shown by beta. Is shown by beta. So, since solvent extraction is used as a method of separation, solvent extraction is used as a method of separation, therefore it is necessary to define the term which describe the effectiveness of separation. त्या सेपरेशनचं किती इफेक्टिव्ह आहे ते कुठल्या फॉर्म मध्ये सांगायचं, तुम्ही सेपरेशन करताय पण ते किती इफेक्टिव्ह आहे, किती चांगलं आहे किंवा किती वाईट आहे हे सांगण्यासाठी तुम्हाला एक टर्मच्या बेसमध्ये सांगावं लागेल. जसं वजन सांगायचं म्हणजे ते केजी मध्ये, ग्राम मध्ये, मिलीग्राम मध्ये सांगतो है ना, तसं हे इफिशियन्सी जे आहे किंवा सेपरेशन जे आहे, सॉल्व्हेंट एक्सट्रॅक्शन आहे, ते सेपरेशन फॅक्टरच्या बेसवरती सांगणार.